the final session of this year's symposium. The energy industry is bigger than just California. It's bigger than across the West. It's bigger than us nationally. It's global. It's worldwide. We are very pleased to have Shell International here with us today. They are going to give us a peek into the world energy model that Shell envisions. Bringing us Shell's latest Sky scenario is Brian Davis, Vice President of Energy Solutions. The sky is the limit, right, Brian? Come on up.
Okay. Hi, thanks, Joanna.
Take it away.
Thank you. Okay. Thank you very much.
Thank you.
I've got a clicker here, fantastic. And Steve and everyone from CAISO, firstly, thank you very much for inviting me here, and thank you to all of you for staying around to listen to me at the end of what has been a pretty exciting and energizing conversation and conference over the last day and a half. I've got the rather sort of daunting challenge of trying to talk to you about expanding the discussion beyond California, beyond electricity, and even into the long term into the future. And so what I'd like to do today is share with you Shell's reflections from our latest Sky scenario, which looks out over the century to come, and what does it take for the world to reach the position of net zero emissions, where in essence we've powered human prosperity through the next century, and we've enabled us to do that in a way that leads us to a place with a healthy life and a healthy planet. And in doing this, I'm sharing the work that has been produced by my colleagues in The Hague and across Shell, and I'd like to recognize them in advance. But firstly, just maybe a couple of words about me. I am Australian. I was born in Sydney, started my career with Shell there. I currently live in London. I spent about 30 years, a bit over 30 years, in fact, working for Shell in all parts of the business. And prior to my current role in Energy Solutions, I was the head of corporate strategy. So I had the great privilege of working with the team that put the scenarios together and figuring out what do we actually do to translate this into an actionable strategy for Shell. And together with our CEO, executive, and board, helps think through the strategy for Shell. So as part of this discussion towards the end, I'd like to also bring it back and share with you a little bit about what Shell's doing and trying to play our part in moving this discussion forward. So let's get going. Firstly, I do need to sort of put this disclaimer up. I'll give you a chance to read it, but in essence, I think what this recognizes here is that we're sharing information and just recognize it in the spirit that it's being shared. Great. So moving on, I'm going to talk about scenarios. And the reason I put this particular chart in is that I am not going to predict the future. And so don't take this as a single universal outcome. It isn't the sort of about predicting single pathways and forecasting, etc. The power of scenario thinking is to think through several individually, holistically kind of consistent views of how the world could unfold, and then think about how do I make my decisions and what do I do in the face of that clearer view of the uncertainty. And Shell's been doing scenarios for something over 50 years now. Our first scenarios in the 60s, and we do them on a regular basis. Our most recent iteration of scenarios were called Mountains and Oceans, and they came out in 2013. And both of those scenarios were mainly focused on factors around socioeconomic and how political structures drive decision making. So the mountains is more sort of centralized control, and ocean sort of implies it's more diverse and the individual has more power than the center. And then we model, of course, the energy implications. And both of those scenarios ended up with a world where the climate changed from pre-industrial levels. The temperature increased by more than 2 degrees Celsius. So a few years ago, we started working on what would you need to believe to make sure that climate change was less than 2 degrees. And so that's the scenario that I want to share with you. It's been public since about March this year. And there were some references to the IPCC report that came out a little while ago. And I will say that actually our scenario is referenced in that report. And we are part of that regular scientific community having these discussions. So firstly, another word about energy. I don't really need to tell everybody in this room how important energy is, but I tend to summarize it by saying that energy really matters. If you get down to the basics of human prosperity and economic development, it's all been driven through access to affordable, reliable, and resilient energy. And increasingly going forward, we need to make sure that we add in there sustainability and cleanliness of the energy system. And so the world has continued population growth. There are about 7.5 billion people now. We believe that grows to 10. That will translate into rising demand, and I'll talk about that in a minute. And there's an ongoing need for energy supply to meet that demand. And I'll talk to you in this scenario work and highlight the dramatic and really quite outstanding and frankly great growth in renewables, electric renewables, wind and solar. And that will be a very important part of solving the problem, but it's not the only part. And so there is continued role, we believe, for fossil fuels in meeting the overall balance of affordability, reliability, and sustainability. And I'll explain that to you. And of course, all of this is about what do we do collectively to mitigate the effects of climate change. But what I would say when we talk about clean energy, let's not forget that most people, when they talk about clean energy, they're worried about local air emissions. And so when you go to many parts of the world that aren't as fortunate as California, where you've tackled early on issues of local air quality in a much more, you're leading in many ways, many parts of the world still suffer from just issues of local air quality. And so, governments and citizens are more worried about that as a first step relative to tackling climate change. But we need to do all of that. I thought I'd start by anchoring the conversation in the energy system today. Because when we're talking about these things, it is a global phenomena. And this particular chart here talks about where we are today in the energy system. And it shows the flows in a rather unusual measure of exajoules per year, which is a lot of joules. But in essence, if you roughly divide the numbers by 2, you get million barrels a day oil equivalent. They're big numbers, and today fossil fuels represents 80% of the primary demand of energy across the world. And you see biomass, etc. Solar and wind, electric renewables, are less than 1%. If you look at the other side of the chart where you get into final energy, so not primary energy, but rather energy consumed, so total final consumption, you again see a tremendous role of hydrocarbons there. And this is a forum, the California Electricity Independent System Operator. So of course you're very knowledgeable on electricity. It matters a lot. Today in global final energy consumption, electricity is only 20% of final energy consumption. So people consume energy in the form of electricity for 20% of their needs. Fuels, and mainly liquid or gaseous fuels, make up the rest of that. So that's where we are today. And interesting as well, look at that losses figure. And we shouldn't forget the importance of energy efficiency, because quite a lot of the inputs don't translate into final consumption. So energy efficiency is an important part of the story. And if you look at the energy system today, it's very large. I think it's something like $55 trillion of capital is in that system. And if you look at the system now, it's kind of a bit like what you would have seen in London or New York in the 20s and 30s, with many of the forms of transport, to the point that was made earlier on by Dan, okay, maybe it's not a 1956 Chevy, it's maybe a bit more modern, lightweight, aerodynamic, digitized, connected, but they still are cars and trains and what have you. And so we need to think about how we transition from what we've been used to in our collective lifetime to potentially a very different and dramatic world going forward. So we characterize the challenges for the 21st century in terms of 2 kind of key things that need to work together. We need to enable development and growing prosperity across the world, and we need to tackle decarbonization. And the challenge of development is really one of affordability and access, and the one of decarbonization has quite a sector-specific approach. And I'll talk about each one of them. But if you look at the chart on the left here, it shows the energy consumption per capita correlated against the Human Development Index, which is a measure essentially of quality of life and prosperity, etc. And you can see yourselves here up in the US, you're kind of very high on the economic development, but also very significant users of energy on a unit basis, more so than, say, European colleagues. And then you get to the other end where you can see there are a lot of people in relatively poor parts of the world that don't use very much. And clearly they want to move over time to become richer, and they will use more. And of course that therefore means that those people who are growing and developing and consuming more energy, that's what's going to drive people more up the curve together with population growth, and that's what drives demand. On the right-hand side of this chart, we look at the different sectors. And there are three sectors of end consumption. If you think about how you consume energy, it's either in the transport sector, so moving people and goods around, or it's consumed in industry. So think about light and heavy industrial use, whether it could be a simple sort of assembly factory, assembly plant, or a large industrial complex, a steel mill, cement, chemicals, petrochemicals, those sorts of things. They consume energy. And of course, the built environment. And by the built environment, we mean offices, homes, factories, supermarkets, the lighting of the roads and the transport infrastructure, etc. And so the energy gets consumed in those three areas. And of course, to generate electricity today, there's quite a lot of fossil goes into generating it. So there's some emissions from power generation if it doesn't come from renewables, first up. Now, if you look at those different sectors, some of them are easier to decarbonize than others. And I could say here that it's relatively easy to decarbonize the electricity grid. I think you've just spent 2 days talking about how difficult that is to do. So that's the sort of relativity of this. It's not easy, it's less difficult to decarbonize the electricity system. I think we can see with the evolution and solar technologies, wind technologies, the continued innovation, we can see a pathway to a world with a very, very significant amount of electric renewables in the grids around the world. But then you get into transport, and this morning's discussion we're starting to talk about some of the challenges of how do you really decarbonize transport, and it's not as easy and straightforward as people think. And then industry as well, and particularly heavy industry, where you need high temperatures, a lot of energy 24/7 to power these industrial factories which create jobs and prosperity and the things we need for our environment, cement and steel. They need a lot of energy. And so decarbonizing those businesses won't be done by electricity alone. So they're important factors to consider. So coming now briefly to Paris and the Paris Agreement, because this is about the Sky scenario, which was how do we respond and meet the challenge of Paris. It is the Paris Agreement, but sorry, it's also the UN Sustainable Development Goals as well. So the UN is very concerned about how do we drive sustainable development. They have a series of goals, and within that, there are 3 that intersect with factors around energy. And the Paris Agreement basically talks about, I'll go back. The Paris Agreement basically talks about we need to hold the increase in the global temperature from less than 2 degrees above pre-industrial levels. And there was a stretch ambition to get it down to 1.5 degrees. And they aim to peak global emissions as soon as possible. And they recognize in the Paris Agreement, which is about 25 pages, that it will require achieving a balance between the emissions of carbon and sinks of carbon. So this introduces this concept of net zero. So when we're talking about a world where we're not increasing the atmospheric CO2 concentration, we will still see some continued emission of sort of CO2 from fossil fuels, and there needs to be sinks that sort of match it from other sources that put it back in the ground. And that, in the state of net zero emissions, would actually achieve what we all collectively want, which is stabilizing and maybe even lowering atmospheric CO2 emissions. So that's what Paris was all about. So how do we achieve that? So I said in the sort of starting point here that in our scenarios family, our mountains and oceans work ended up with increases in temperature greater than 2 degrees. So the Sky scenario was set out to say what is technically feasible, economically feasible, industrially feasible, that would actually give us a set of conditions that would deliver that objective. And we basically looked at the work that we had done under mountains and oceans and put together the better features of each of those 2 scenarios and constructed a scenario that does, in fact, deliver this outcome. And I'll talk to you a bit about in the rest of the presentation through some of the attributes of what that looks like. But firstly, I'll try and unpack these rather than... If you think about when you're doing scenarios and thinking about the sort of things you need to take into account when you're projecting out over the medium and long term, some of the uncertainties to take into account has been visualized here through this sort of analogy of a plane sort of flying blissfully towards this future of a better life with a healthy planet. And of course, it will encounter turbulence along the way. And the sort of elements of uncertainty that we need to consider here are things such as demand growth, that demand for energy can have shocks linked to economic activity. It can have other factors in there. You actually get interesting phenomena of things like efficiency rebound, where you would think that if we have new technologies that are much, much more lower cost and efficient, then that would reduce demand. But something as simple as a lot of the energy efficiency in the internal combustion engine for cars since the 70s to now has basically gone into allowing you to have bigger cars with more stuff in it, of air conditioning and a lot of digital and connected devices, etc. So actually the miles per gallon hasn't changed as much as the underlying sort of efficiency of the engine that's within the vehicle. And likewise with LED lighting has made actually, it's relatively cheap to have now lighting. You go to Times Square or you go to my train station in London, and Waterloo Station in London has big LED-driven billboards doing all the advertising. So you no longer have people sort of slapping up posters, stripping them off and doing it again. It's all electronic. And so that consumes a bit more energy. So when you get technologies that are cheaper, people find new ways to use them. So we've got to factor that as well. We still have a lot of coal resources, and those resources are often in places that are developing nations around the world, where they're looking to have affordable energy, and they're trying to balance the fact they've got their own indigenous resource, which is relatively cheap, with a need to sort of create jobs and development. And there are some difficult sectors to decarbonize. I mentioned that earlier on, industrial particularly, and some are transport. And likewise, we call a concept of stalled technologies, which I'll come back to at the end as well. And stalled technologies are things we think are critical for the long-term solution, but right now, nobody's really giving them the support that's necessary for them to achieve the sort of commercial viability and scale that's necessary. And I think two of those that I'd call out and talk about is carbon capture and sequestration and hydrogen. So moving through, so essentially what we did in our scenarios here, and I'll unpack it, is we started in current reality, and we looked at what are the current nationally determined contributions that every nation signed up to in Paris. And if you actually look at it, that is more than 2 degrees. So the current kind of voluntary commitments of nations don't actually solve the problem. And so what we did in Sky is to say, well, let's assume in the next cycle you get a ratcheting up and people start getting more serious about it. And maybe somewhere like China starts to actually saying, I'm going to make a commitment to start reducing my emissions rather than maybe just capping them. And then in the next cycle, in the further 5 years' time, you'll see more and more nations making more and more commitments. And so maybe India will start to be making commitments to peak emissions rather than just talk about intensity. So our initial scenario starts to sort of move out, below the others, and then over time we start playing out technology options to get to the future. So that's how we built the scenarios, anchored in reality, and then linking it with what's technically and economically possible. When you're doing this work, you need to combine many, many factors together from society, markets, and governments, because all of those things interact. What do consumers want to do? What will consumers do in terms of making choices? Are they willing to pay more for a lower carbon solution? So far, we tend to find people would like it if it costs no more, but if you have to pay more, not everybody is willing to pay more for a lower carbon solution. And actually, there are a lot of places in the world where they can't afford to. They just need energy in its own right. And governments have different roles to play, and the attitudes of governments around the world are not, uniform. So you need to take into account the realities of local government conditions and local markets and societal expectations. So we've done all of that in our scenario work, and now we kind of get to a bit of what does it start translating to. So this chart here is a summary of how the energy system globally is composed in terms of primary energy today, and in the Sky scenario in 2070. And in 2070 in Sky, we get to net zero emissions. So from 2070 onwards, there's no increase in atmospheric CO2. And in that world, today you see the 80% of fossil fuels and a very small amount of wind and solar. But what's striking here is firstly you see the donut, or the size of the energy system, doubling or increasing significantly. But look at the tremendous growth in solar and wind. So together there's something like 40+ % of the global energy system will come from electric renewables. And also look at the fossil fuels, natural gas, oil, and coal, are only about 20%. So we moved from a situation where 80% of the fossil fuels are providing the energy today to where there's only 20%. But it is still there, and it's there, and we have it there combined with carbon capture and storage. So that quite a lot of the emissions from burning that fossil fuel and using it are captured and put back in, and stored safely in the earth for a long time to come. We also, in that 2070 scenario, there's a brown bar that shows bioenergy. And I'll talk a bit more about that later on, but essentially, that is where we're using biomass and growing, sustainable, renewable biomass and using that for energy provision, either as a fuel or, in its sort of solid form, for electricity and other uses. And you can combine carbon capture with that. When we play out the scenario, there's 7 essential elements that are captured on here that we need to take into account, starting with a view on how does the electrification of end consumption move. There's a lot of talk about increasing electrification. Electric cars are the most obvious one. I'll share a few thoughts on that in a minute. You need to grow the energy system and new energy systems, no more visible than that previous chart, seeing 40% from wind and solar. So we need to continue to see those new low-carbon sources of energy grow. We need energy efficiency, we need carbon pricing, we need technologies like carbon capture and storage. But we also need to tackle not just energy-related CO2 emissions, we need to tackle the implications of things such as deforestation and land use changes, which add additional CO2. They reduce sinks and they add to the increase in atmospheric CO2. So in our scenarios, we need to see an end to deforestation and in fact a reforestation. So planting trees again, so you're starting to capture CO2 in the form of reforesting areas. And the last one on the bottom is really, really critical, witnessed by the earlier session, is the role of you and I and every consumer in the world. What do we do to help drive this change? And I think that's a very important attribute to consider. So I'm going to talk through a few charts very briefly to kind of give you a bit of a flavor. And at the end of it, I'll give you a link. And the key thing here is that this information is available on the web. You can go and drag it down, the data, and read it at your own leisure in detail. But I think this chart particularly is an interesting way of looking at the tremendous opportunity from deep electrification of the energy system. We're going from 20% to potentially 50% by the latter part of the, this century. We're also seeing still, despite that tremendous growth in electricity, there's a continued need for liquid fuels, gaseous fuels, and solid fuels. And so in that liquid fuel space you'll see oil, but you'll also see biofuels. In gaseous fuels, natural gas complemented with hydrogen, and coal and biomass will continue to exist. A word on the pace of electrification. Sorry about the... We need to reach from 20 to 50%, we have to go much, much faster at electrification than we have been doing to date. We're doing about 2% per decade of increasing electricity as its share of end consumption, which I guess is kind of good news for a more electricity-centric community. But you've got to basically go, 3 times faster in the future. So that's actually a great opportunity and somewhat of a challenge as well to tackle. And if you look at electrification, it's different sector by sector. I introduced the sectors earlier on. And if you look at what does that 20 to 50% mean when you break it down by sector, firstly you see that the built environment or buildings, we believe that buildings are relatively easy, and again I use the word relatively easy to see a very significant amount of electrification start to happen. Think about the main sort of non-electric source tends to be if you're using, say, gas or some fossil fuel for heating of the building. If you're able to go to heat pumps and electrically driven heat pumps, you can increase that quite significantly. Transport we talked about before. Transport will dramatically increase, and its share of electric in transport will be very significant, but it won't be 100%. Just think about planes and long-range heavy-duty transport. We think they're much harder to electrify. Light-duty we think is easier to do. And a word on then light-duty vehicles and electric vehicles. So in our scenarios, we said, let's really drive hard on assumptions of adoptions of electric vehicles for light-duty passenger consumption. And so in our work, we have, in this particular scenario, by 2030, more than half of all sales of light-duty vehicles around the world are electric. And eventually, by 2050, you're not able to get anything other than an electric vehicle. So that's a pretty aggressive rate of adoption in terms of new car sales. What I would say is it's also worth thinking or remembering or maybe being aware of that today there's about 1 billion light-duty vehicles in the world. So there's 1 billion cars in the world, and there's about 100 million a year being manufactured. So we have to also deal with the fact that there's a stock or an existing fleet of vehicles that will need to turn over time as well. So you still see, even though that's happening now in new car sales, you still see an increased or a growing need for oil in light-duty transport for some time to come, and eventually petering off. Energy efficiency, I think, is a really, really critical driver. I mean, the easiest thing to do is like the negawatts, or don't actually consume the energy in the first case, because that saves you money and it puts less total stress on the system. And energy efficiency is an increasingly important role globally. Again, I think it's one of the places where California has led in many areas in efficiency standards for buildings and likewise. And you need to do more at the device level, making our fridges and the individual devices much more efficient. But also we need to look at it from a system point of view, because the world is moving more and more to urban environments. And I think understanding and designing urban environments that are much more inherently efficient allows you to basically provide, a quality of life with less total energy need. So just think about, if you can do your urban planning in a way where people live relatively close together, or they've got transport links that are easily electrified, then that makes for an inherently more efficient city and therefore less energy. And look at the split between OECD and non-OECD. This trend of urbanization is really, really stark when you get to the developing world. In Africa, India, places like that, and China's been through this themselves. And they're really quite significant challenges. We'll need a CO2 policy signal. We need a CO2 price signal, an economy-wide price signal for the value of emitting carbon for this scenario to play out, so that people are able to make the economic trade-off between different sources of fuel, different modes of using energy, and understand how you price in and choose the one that is the lowest cost at an economy-wide basis for mitigating CO2. And that will ramp up over time as more and more governments around the world put mechanisms in place to send those signals into their markets. And this is basically a play out of those two donuts as you see over time, and you can see, the growth in fossil fuels will start to decline, and you'll see a significant growth in the top through electric renewables. But there still will be oil and gas for some time to come. And what drives fossil fuel, whilst each one of them will peak at different times for different reasons, we do believe because of those difficult to decarbonize sectors of the total energy system, there'll still be places where molecular fuels, fossil fuels, are the most affordable way to provide energy to that particular part of the economy. And probably natural gas is the one that has more growth for some time to come, but then will peak off. A couple of words on carbon capture and storage. It's a technology that I mentioned is one of these sort of stalled technologies. It has been deployed around the world, and we believe it does work, and there's a lot of evidence it does, but it's sort of stuck a little bit that it's not yet economic, and we don't really have governments around the world wanting to support and help it along. But just in case you're not fully familiar with what we're talking about, The concept of carbon capture and storage is that you capture from large concentrated sources of CO2, you capture that CO2 and then you transport it and you store it safely in the underground reservoirs for long-term storage, and therefore you avoid it being emitted to the atmosphere. And this is a technology that could be applied for things such as cement and steel, which actually produce CO2 as part of their process. And you could capture that CO2 and put it in the ground and would help reduce the carbon intensity of those essential components of the economy. And likewise, maybe for power generation. And interestingly, if you combine the same technology with bioenergy, you have the potential to create a negative emission source. So if you sustainably grow bioenergy, we show it as forests here, but it could be energy crops, depending upon your particular climate and agricultural local realities. You can pay many, many different sorts of energy crops. If you take those energy crops and then you use them to generate fuels and energy, and you capture the CO2 that's associated with combustion and put it in the ground, you've in effect sort of captured the CO2 from the atmosphere through a biological process and then stored it in the ground. And that will be a negative emission from the atmosphere. And so if you start doing this at a significant scale, you can help move us towards that world of net zero emissions. I did talk briefly about deforestation at the start, and this is a very, very important part of our scenario. What I would say, when we've taken our work of our energy systems, we've done all of that thinking, looking at all the technologies, run the economic models, and we've given that information over to our colleagues at MIT who do climate modeling, and they've run it through and said that that particular scenario has a fairly high chance of being a 1.75 degree world, so less than 2 degrees. So we've come up with what we had intended to do, which is to see a 1.7, less than 2. Then the question was, what would you need to believe to get to 1.5? And it more or less, you have to basically do additional levers. You could pull harder on all the various things we're doing them a bit faster, but you also need additional levers to pull. And one potential lever to pull is reforestation. And we recently talked about the fact that you'd need to probably reforest an area the size of Brazil to get us to 1.5. So it's it's possible, but it's quite significant. So sort of coming a bit towards a close in my talking around the scenarios. To meet the Paris ambition, you're basically talking about this rewiring, this massive rewiring of the energy system to one where you've got a lot of electric renewables in it, you've got all these other technologies, and you've got these things such as CCS and biomass all in the play, and it's got to happen in 50 years. And it may seem a long time, 50 years, but actually this system is very large. It's got a lot of installed equipment and stock. And the annual spend we're talking about is $2+ trillion a year. It takes time. It's taken us a long time to build the one we already have. We have to double it and decarbonize it. So it's a massive challenge to do that in 50 years. But it can be done, as we show in the scenario here, but it requires governments and private sector to work together. The government plays an important role in promoting those pre-competitive technologies. They did it very well for supporting solar with feed-in tariffs and schemes like that. They need to help with infrastructure and market design. And the private sector needs to play a role in terms of commercializing, driving the innovation, and taking the products to market. The amount of money to be spent is so significant that we do need all of the sort of private enterprise behind it. It isn't something that governments alone can, if you like, subsidize your way to the solution. So I'd like to kind of close that piece around the scenario by talking about that, in essence, it is possible to do that, to get to this world of net zero. And net zero is where there will be continued use of fossil fuel, there will be continued emissions of CO2 from certain industries, certain sectors, but they will be netted off by other places where you're actually capturing and storing CO2, so the world is in balance, and the atmospheric condition hasn't increased and we're less than 2 degrees. But of course, to get there, as you can get a bit of a sense, is, it's not easy. It's not even easy to decarbonize the California grid, let alone to do all the other things I've talked about. And it really starts with, what do we do now? And I think we all, depending upon your individual role, you all have something you could maybe take away, you could do differently to help us move it in the right direction. So what I'd like to do just very briefly is just tell you a little bit about what we're doing at Shell. And maybe not everybody's familiar with it, but at Shell, we are an integrated energy company. People sometimes think of us as an oil company, or maybe an oil and gas company. But actually, we have a very diversified portfolio around the world in oil and gas. We produce, refine, trade, and market oil and gas around the world. This information is on our public website as well. But we're basically continuing to make sure we can provide energy to meet the world's growth. But we're also layering in an increasing need to tackle lower carbon energy solutions, which is our new energies business. And you can see there our purpose is about powering progress together by providing more and cleaner energy solutions to the world. In November last year, our CEO announced our net carbon footprint ambition. And what we've talked about in the Sky scenario is that the world society needs to reduce our intensity over time to solve climate change. And so as Shell, we're committed to doing our piece of that and looking at the total emissions of our products. And we've set ourselves some ambitions here of what can we do to start reducing the emissions from the portfolio of products that we sell to you and other people and make them lower carbon over time and eventually move in line with society. At the moment, our portfolio is relatively more carbon intense than the societal average, primarily because it's more oil and gas and we don't have a strong renewable power business and some of those other low carbon. But we're intended and committed to doing our bit to be a force for good in society. And part of that is our new energies business, which I'm a member of the leadership team of. And our new energies business was created a few years ago, and it focuses on two things: new fuels, which are essentially low carbon fuels for transportation, biofuels, hydrogen, electric mobility. And we're also focused on power and building a significant integrated business for Shell in the power business. And we look at the power value chain of the future, not necessarily the one of the past. And we don't all necessarily know all the answers, but we're committed to sort of exploring and seeing how we can play a role in addressing this tremendous opportunity of increased electrification as it spans and bridges the economy into mobility, etc. What have we been doing? This chart here is the eyesight test, I guess. I don't intend for you to see it or to reread it all, but essentially what it highlights is that two things. One is that we actually formed a renewables business in 1998, Shell Renewables, and we were an early investor in this space. Maybe we were sort of in the wrong places too early at time, but we learned a lot from it, and we sort of been a bit of a pause till we thought we were ready to be able to deploy at commercial scale. And so since 2016, we've increased very significantly our activity. We're spending between $1 to $2 billion a year in this space, which is a significant amount of money. Shell as a company spends even more than that, so it's a relatively small percentage of Shell's total spend, but it's a very significant expenditure. And we've been very active across a whole range of areas that are capsulated in this particular chart, investing in energy solutions, my area, so everything from buying energy retailers to distributed energy companies, energy access. We made 4 investments in companies that are looking to tackle rural electrification in Africa and India, the role we can play there. We've bought solar developer platform, Silicon Ranch Corporation in the east of the US, we bought into recently. And we're also a significant player in biofuels and wind and tech venturing. And finally, maybe to make it a bit more real to many of you, I thought I'd pull a chart up on what are we doing in California. And so in California, just sort of down the road or relatively down the road from Sacramento in Stockton, at our fuels distribution terminal, we recently started up an on-site solar project that powers that terminal's power needs. And that was part of a way of us learning what does that take to sort of, embed these technologies within our operations and do our bit to reduce our carbon footprint of our operations. We are a significant investor in interesting, innovative technology companies, and there are a lot in California, and there are a number listed there. One that I'd call out is Axiom. I think Axiom's an interesting one. They're doing kind of refrigeration battery or cold storage, or sort of shifting energy through the form of basically producing sort of ice at night and using it during the day for peak demand shaving. And we think that's an interesting technology of energy storage in the form of cold. Ample is a battery swap company. and jelly as a sort of just a battery optimization. And of course, we've been in hydrogen for a long time. Our first hydrogen station was 1999. We built one in California about 10 years ago in Torrance in Southern California. And we're growing from 2 to more and more hydrogen stations. And it was discussed in the previous session, the role of fuel cell vehicles and hydrogen. It does have a role to play as part of the mix. And we're doing our bit to bring hydrogen refueling infrastructure to Californians as well. And we have a team of people that are growing up in San Francisco and a growing team of folks. So with that, as I said before, we have a lot of information on the web. I've only sort of briefly touched over a lot of it. It's a very rich resource. The team who've put it together would love to hear your comments. I would probably conclude just by saying that hopefully I've given you a sense of maybe a different perspective of the energy system, a broader global one, some of the elements that are quite challenging to do, but we actually feel that it's technically, economically, and industrially possible to do it. It will take time. It's not easy, but we've all got to move and start moving now in the right direction. So with that, I think I'll...
Thank you, Brian.
Stop. Thanks.
Thank you. So before I entirely let you off the hook, may I take the liberty to maybe ask you a few questions?
Sure.
So one of the facts you mentioned was that by 2030, 50% of all car sales are going to be electric vehicle. That really feels like it's around the corner, right? In California, we have the highest adoption of electric vehicles, I think, worldwide. Mm-hmm. And we have about 400,000 today. So how do you think we're going to really get there? Is there a particular tipping point?
Yeah, I think to get to that level, it'll ultimately come down to consumers being willing to make the choice to buy an electric vehicle, and that was Adam mentioned that in the previous session. And I think the factors that come into will you choose to buy an electric vehicle will be around range and range anxiety and performance, as well as affordability. And so if you can make battery technology better and better so the range goes further and further, then you're less concerned about range anxiety. Obviously, if you've got the infrastructure in to charge it, that also helps. And then, of course, affordability. And affordability will come from two factors. One is just with industrial scale, then these become cheaper, but also governments can put subsidies in. And so we're seeing in the places where it's adopted very significantly, there's a strong government incentive and a lot of incentives that kind of bring the affordability gap forward. But I think the real tipping point to me is eventually when it's a standalone, economically rational decision to choose EV over the alternative, then I think you'll see more and more people go at it.
Okay. There's definitely more choices, so we're seeing more and more of that now. You also describe in your presentation that how electrification plays out by sector. Mm-hmm. How is that different geographically? North America versus other parts of the globe.
It's a good one, and it's maybe a chance to just sort of call out the 1 to 2 billion people in the world that don't have any or have less than 4 hours of electricity. So that's one lens to think about it, is there's about 1 billion people who have no energy, no electricity. So for them, even having it's great. And there's another 1 or 2 billion who have a connection that's less than 4 hours, which isn't actually particularly helpful. A fridge doesn't work with 4 hours of electricity.
No,
you don't know,
it
doesn't work. So that's an important element, and our energy access team is trying to figure out what role Shell can do to try and solve that problem. But then you also look more generally at the developed and developing world. At the extreme, I mentioned 20% on average. At the extreme, Norway is 50% electric, so 50%. And that's partly because as a history, Norway had all the fjords and a lot of hydro. So their kind of advantaged energy supply before they found oil and gas was their hydro resource. So they built an economy with a deep amount of electrification. And so they got 50%, Sweden's like about 40. At the other end, you've got a place like Nigeria with tremendous fossil fuel resources with very, very low electrification of their end consumption, partly driven by the unreliability of the grid.
So Norway's clearly leading the charge?
Well, Norway certainly is an example we could all look to, but when you look at, but they've got a certain advantage too for the experts in the room. They've got a lot of hydro. Mm-hmm. So if you've got a lot of hydro, and it kind of makes it a bit easy to run with very high penetrations of electricity.
Yeah. That makes a difference. Okay. My last question for you. So the UN IPCC report on global warming that just came out, it warns that the consequences of climate change are more severe, are going to happen even faster than we probably anticipate. So given that, are the Shell scenario teams, frantically regenerating your scenario to maybe accelerate things, or do we stay the course?
Yeah. So the IPCC report came out a week or two ago, and actually our scenario is referenced in that report. Our scenario is, it gets us to there, it just has different levers and plays it out differently over time. And I think we should look at all of them, because the first thing is ours isn't the right scenario, theirs isn't necessarily the right scenario. You should allow a bit of space for multiple. I think what all of it says is that if you want to go faster towards 1.5 degrees, then you've got to do two things. You've got to just do everything you're doing faster, because it's about how much gets emitted to the atmosphere. It's like a stock problem. So the sooner you can start taking action to peak and reduce emissions, then that sort of buys you more time before the extra technologies come in. And then the other thing is you need to pull every lever you've got. It's a kind of an and, so do everything you can, and maybe pull a few new levers. And so that's this point about reforestation. And at Shell, we're looking at that as potentially an interesting extra lever as to how do nature-based solutions start playing a role in helping to kind of offset.
Well, we have our work cut out for us, no doubt.
We all do, collectively,
yes,
indeed.
Yes, we do. Well, thank you very much, Brian. Really appreciate it. Thank you, sir.
Yes, thank you very much.
Ladies and gentlemen, Brian Davis. Thank you for bringing the Shell Scenario Sky to life for us. Well, ladies and gentlemen, the 10th Annual Stakeholder Symposium is about to come to an end, but our transformation continues. With the commitment of all of us in the room, we will continue to transform the energy industry. There's no more exciting time than being in the energy industry. Who would have thought 20, 30 years ago, we would have been saying the energy industry is an exciting place to work. It really is, right? It's electric. One person in the audience, yeah. Well, I hope that we brought you a program that was not only interesting, but one that has been thought-provoking and prompts new ideas. It was my absolute pleasure to be your MC. Thank you for being such a gracious audience.
So on behalf of the Board of Governors, the EIM governing body, certainly the executive team at the ISO, and all of us from the ISO, we truly appreciate the engagement we've had with all of you. Also, particularly want to be thankful of the presenters. They've come from far and wide. They do it on their own dime. They're happy to be here to engage with all of us, and we're most appreciative of that. We have lunch now. We're done with the sessions in the symposium. We hope to see you all again soon, and thank you so much.
Thank you, everyone.